For my presentation, we're going to talk about managing your file system. We're going to talk about why we have a file system, the types of file systems, limitations, benefits, and then we're going to have a demonstration of shrinking a volume, enabling disk quotas, and viewing alias named files. So why do we need a file system? Well, say you're looking for a credit card bill from 8 months ago within these 2 stacks of papers. They would take you a long time. It's not very efficient. You would probably go crazy and set it on fire. But if you had it filed like this, all you have to do is find the correct file, and it's right inside that folder. You pull it out, and voila, you're done. It's more organized and efficient and less stress. Well, computers are the same way. So if you have many files just placed all over your computer and you want to find a particular one, well, if your computer doesn't have a system, it has to leaf through every one to find the correct one, which could take some time. So the types of files: file allocation table, new technology file system, universal disk format, CD-ROM file system, and an extended file allocation table. Let's talk about file allocation table. This is also known as FAT. It is supported by all Microsoft operating systems. Regardless of what kind you have, you can support a version of FAT. Now, I have chosen 3 versions to represent, but there was a 4th. It's FAT 8, which was a standalone for the 8086 chip. But we're going to talk about 12, 16, and 32. And the reason they're named that is because they are labeled according to the number of bits used to address clusters or blocks of data. So first we're going to talk about FAT12. FAT12 uses 12-bit addresses, allows up to 4,096 addresses, cluster size from single sector to 40 kilobytes. The maximum partition size is 16 megabytes. FAT16 is 16-bit address, allows 65,536 addresses. The cluster size depends on the version of Windows you have. For some, it's 32 kilobytes with the partition size of 2 gigabytes. Then others are 64 kilobytes with the maximum partition size of 4 gigabytes. FAT32 uses 32-bit addresses, allows more than 2 million addresses. The cluster size can reach up to 32 kilobytes. The maximum size of partition is 8 terabytes. But the cluster size is according to your drive size. So it'll fluctuate at the size of your drive. And one other note, since Windows XP, the FAT system has not been used, and it cannot be used with any files larger than 4 gigabytes. So some other limitations and benefits: fault tolerance. It just makes a copy of the table stored in the partition. That's it. There's no other fault tolerance. The storage, as it says, is inefficient. Once it uses a cluster, even if that data does not fill up that cluster, then it's not usable. So there's wasted space if it doesn't fill it up. The limited security is just that. It's limited. It only uses simple attributes to specify the system hidden or read-only file. There is no user-based security. Now for some of the benefits. This is great when you're using a legacy operating system to multi or dual boot. It's simple to understand. The third-party utilities support this. It's great for a simple file and folder requirement or where no security is needed, and which is great for cameras, media players, or USB memory. So my questions for you: why do we need a file system? Name 2 versions of FAT. Name 1 limitation and name 1 benefit. For the next one, we're going to talk about New Technology File System, which is NTFS. It has a lot more to offer, such as more secure and efficient, bigger partitions, the operating system specifically designed for NTFS versions, and stores files and folders similar to the FAT system. So the next slides of information is going to be a lot. So I've broken them up, but I'm going to list all of them, and then we're going to go into a little more detail into each one of these. First slide, we're going to talk about log file and checkpoint consistency checks, automatic bad cluster management, transactional NTFS, Unicode, and 8.3 DOS format. The slide after that, we're going to discuss alternate data streams, encrypting file system, file and folder permissions, and compression and disk quota. For the last one, we're going to talk about shrinkable and extendable partitions and volumes, volume mount points, symbolic links, and sparse files. First up is the log and file checkpoint consistency check. So everything is kept on a master file table, which is a relational database that provides starting point for accessing any file or partition. What this means is that any changes that are made to a system file are kept in this master file. It stores and creates these checkpoints and the sequence numbers so that if you make a mistake, you can go back to another point where it was working. This is an automatic process. You don't have to enable anything. Automatic bad cluster management. This keeps a record of all unusable clusters in a file. Once a cluster is bad, it's moved to this particular file. If that cluster is still in use, it just moves the data to another cluster. Transactional NTFS, also known as TXF. It uses log file and checkpoint to protect file data, meaning this helps with errors. It uses atomicity transactions, which means that if one part of it does not work, then none of it works. So if there's a problem in an application at one particular spot, if there's an error in the code, then none of it will work. And if these applications don't use transactional systems to write the file, then it's not protected by this transaction and TFS. Unicode and 8.3 DOS format. So Unicode is files that can use international character set. 8.3 DOS format, this is where files have two names. One is called a long file name. It's limited to 255 characters and can contain valid Unicode character. Or the 8.3 file name, which is also known as an alias. They have a maximum of 8 characters, then followed by a period and a 3-letter file extension. There is a process that it goes through to create this name. And you can see these names, which I'll show you later in the demonstration. But this allows over 300,000 unique aliases. And if you delete a long file name, it deletes the alias as well. So for the next one, we're going to talk about alternate data streams. This is also known as file system forks. Now, it was added to support Mac hierarchical file system. And what it is that you have one file that's unnamed that stores the byte data, and another named stream that stores the formatting, or formatting, thumbnails, all the other information. This is also very convenient for hackers. Encrypting file systems, this is your local access protection tool. Basically, it locks up your hard drive. It encrypts your hard drive. You would need keys to decrypt it. But since it is a local access, if someone were to get into your hard drive and then download all your information to something that doesn't support EFS, then it will decrypt it. If you send it over email or network, it's decrypted. It doesn't stay. So this is just local access. Like if somebody steals your hard drive and tries to go home and plug into it, then they would need the keys to get in. File and folder permissions. All your permissions are in a hidden list called the Access Control List, the ACL. If you move a file or folder, it resets the permissions. Now your compression and disk quota. Compression is used to save disk space by reducing the size of data. All right. All this is done by the CPU. So there's two types of compression, lossless or lossy. Lossless is when it decompresses, it restores all of the data. And lossy is when it compresses, it gets rid of what it feels is unimportant data. So when you open it back up, there could be some missing data. I also want to mention that some files aren't meant to be compressed. When they're compressed and decompressed, it balloons the size of them, which puts a strain on your CPU. So bear that in mind if you compress any of your files. Disk quota. Disk quota limits the amount of space used per user on a partition. It's not set up by default, so you have to go in and through Disk Management Console and set up. Now, if you want to set the limitations for each user of what they can use, you'll need to go to the Quota tab and enable that, and then set the amount. For specific limits on a user, you do quota entries and it will override the defaults. If a folder or file changes ownership, that changes the amount of data that belongs to the user. Now we're going to talk about shrinking and extendable partitions, which allows the resizing of partitions without reformatting. This is kind of self-explanatory. You can shrink or enlarge your partition or volume. Your volume mount points. This allows linking to volumes without a drive letter. This is also called junction points. They are folders that are linked to a volume. You don't have to use the drive letter. You can have different points that direct to the same volume. And when you create these, your folder has to be empty to be able to convert into a mount point. Symbolic links. Symbolic links are also called soft links. They were added as support to the Unix-based POSIX applications or portable operating system interface. This is a file system object, and as you can see, it points to any folder or file on any volume or partition, which is very handy. And the sparse files. Sparse files are where 0 blocks are not stored on the disk. It's basically ignored. So the benefits to that is like virtual machines where it saves disk space. But if you have an application that you're using, it can actually balloon the size of the application. Your disk management will be inaccurate. So questions. What does NTFS stand for? Which technology uses log file and checkpoint to protect file data? What is file system forks? And what technology allows the linking of volumes without a drive letter? So for our last set of slides, we're going to talk about the last three systems. Universal Disk Format, UDF. This is a standard defined by Optical Storage Technology Association, or OSTA. It allows the interchange of files between operating systems. So it does not matter what operating system you have, it's going to run this disk format, which is usually on DVD. Well, now we're going to talk about CD-ROM file system, also known as CDFS. This is also known as the ISO 9660. It allows data to be written and read on CDs. This is for CD-ROM media only, and it's limited by file names and the depth of the directory structure. There isn't that much support for this on the newer operating systems, but it is not operating system specific. The Extended File Allocation Table, or exFAT. This file system is used in large portable memory devices. It's licensed by Microsoft. It's not an open source. And this is what we use in our flash drives. Because our flash drive sizes are growing, this extended file allocation table is needed. Okay, so now we're on to questions. What does OSTA stand for? What standard does CDFS follow? And what kind of technology is used in flash drives? So that's the end of my PowerPoint. And now we're going to go on to a demonstration. We're going to use VMware. I have my Windows 7 open. Yes, my license is expired. I already know. But we're going to shrink a volume or partition. So you'll want to click Start and go to your computer. Right-click on Manage. Now you'll see mine's already open, but if this is not open, then you'll want to go to Storage and then Disk Management. And you click on this and open it up when it's ready. You see that I have one partition. We're going to make another. We're going to have to shrink this one. You can see these lines on the partition. This lets me know that this is the one I am clicked on. So we go to Action, All Tasks, Shrink Volume. So right now it's checking to see how much we can shrink. And make note that if you have a file that is not moved or unmovable, which is why it's a good idea before you do this to do a defragmentation. I'm just going to let it choose for me. You can decide how big you would like to do this. As you can notice the information, you cannot shrink a volume beyond the point where any unmovable files are located. So you defrag, it can change this, but we're going to leave this as it is. So I'm just going to go ahead and shrink. And now you can see that I have 25 gigabytes of unallocated partitions. Make sure you clicked on this and that the lines are obvious before you start working in it. We're going to go to All Tasks, New Simple Volume. So let's make it the size at 500. We're just going to demonstrate the difference. It assigns a drive letter, and you can choose the type of file system you want. I'm going to leave it at NTFS. Perform quick format. Let's change this to DATFOL 1. Hit next. It gives you a summary, and then click Finish. It's going to create it, format it, and it'll be ready. And it tells you, do you want to format it? No, cancel. As you see, we have a healthy primary partition named Data Volume 1, or Drive E. So that's how you would shrink a partition to add another. Let's go back to this one. Right-click on it and go to Properties. As you can see, we're in the Properties of Local Disk C. And we want to go to Quota. Quota, you can see, the disk quotas are disabled. Well, if you want to enable them, you would click Enable Quota Management. You can limit the disk space, and this will give them a warning. Say you want to limit them to 1 gigabyte, and you want the warning to come up before then, so you set it to like 600 megabytes. And this will limit them, and will give them a warning and limit them from using too much space on a disk. Which we're not going to do this. We're going to change this back to do not limit disk usage and just leave the enable quota management. And then I'm going to apply, and we're going to watch this light change from red to green. So now it's rebuilding. So it's green now, and that's how you would enable disk quota. Showing alias files. We need to go to the command prompt. You can type it in here. Since I've already had it open, I'm just going to click it from here. This is already directed to our drive C. We don't really have to change this. But if there was another drive that you wanted to look into, You could. And remember what alias files are. They are the second file that is created when you have a long name file. So you'll hit tir, and you see that it shows your long file names for each one of these. So if you were to type in dir \x, this not only shows you now the long name file and then the alias as well, as you can see. Compare that to this one here. So if there is a directory that you want to see what the alias is, then you can just go into the command prompt and type this in. And that is the end of my demonstration and presentation. Thank you.